You clicked because you want to know how fast your model really is. But raw tokens per second is a dangerous metric that hides the true cost of speed. If you optimize for that number alone, you risk building a system that talks fast but says nothing true. By the end of this video, you will understand why chasing higher throughput often destroys the very coherence and accuracy your application needs. We have spent years obsessed with a single number. We look at benchmarks and see tokens per second as the ultimate measure of performance. We treat it like a speedometer on a race car. The higher the number, the better the machine. But here is the thing. That speedometer tells you nothing about the quality of the road you are driving on. In the world of large language models, we are seeing a fundamental disconnect between raw inference throughput and generation coherence. Recent research challenges the industry's obsession with this metric, revealing a critical trade-off where pushing for higher tokens per second often degrades the quality of the output. Consider the specific mechanics of how a model generates text. When you request a response, the system does not just spit out words, it predicts them one by one, or sometimes in small groups. This process is governed by complex mathematical constraints. A pivotal study titled Speed and Conversational Large Language Models, Not All is About Tokens Per Second, argues that optimizing for raw speed fails to capture conversational efficiency. The latency and interaction flow vary significantly based on context length and the dynamics of the task. This means a model that looks fast on a benchmark might stumble in a real conversation. Let us look at a specific technique called speculative decoding. This is where engineers try to accelerate wall clock inference by predicting multiple tokens simultaneously. The theory is sound. If the model can guess the next 2 or 3 tokens at once, it should theoretically run 2 to 3 times faster. This throughput gain is significant. However, this acceleration introduces a risk. The system works by having a smaller speculator model draft tokens, which a larger base model must then accept or reject. If the speculator's n-grams lack high quality, the base model might accept incorrect drafts. This can increase hallucinations. You are getting words out faster, but you are also getting more wrong answers. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Now consider the hardware itself. We often assume that a powerful graphics card is always the answer, but production anomalies complicate the narrative. Users have reported CPU inference outperforming GPU setups by over 5 times in specific configurations. This happens when the GPU is not utilized efficiently or when memory bandwidth becomes a bottleneck. Conversely, benchmarks for libraries like llama.cpp show latency jumping 5-fold when decoding multiple tokens in a single pass. This happens on hardware like Apple M1 chips. Increasing the batch size from 1 token to 2 tokens can cause a 5 times latency jump on certain devices. This directly degrades generation coherence and intertoken timing. The model pauses longer between words, making the conversation feel robotic and disjointed. These findings suggest that raw tokens per second is a misleading metric. It can obscure architectural bottlenecks and quality degradation. High-throughput benchmarks frequently ignore the conversational dimension. The cost of maintaining long context windows and managing attention mechanisms leads to slower effective generation speeds. This correlates with increased model drift and hallucination rates. Production systems often sacrifice generation quality for throughput by forcing aggressive batching or reducing context retention. This creates a false equivalence between tokens per second and usable response quality. You might have a system that generates 1,000 tokens a second, but if it forgets what you said 3 paragraphs ago, it is useless. The primary knowledge gap remains the lack of standardized benchmarks that correlate specific throughput thresholds with hallucination rates in long context scenarios. We need to stop treating speed as the only virtue. We need to shift from throughput-centric metrics to holistic evaluation frameworks that prioritize context retention and factual consistency. When you design a production system, you must ask what the user actually experiences. Do they get a fast answer that is wrong, or do they get a slightly slower answer that is reliable? The answer to that question determines the success of your application. Here is the insight that changes everything. The highest tokens per second number you see in a paper does not represent the speed of a real conversation. It represents a best-case scenario where the model guesses correctly every time. In the real world, the model must constantly verify its own predictions. When you force it to guess multiple tokens at once to boost that number, you are increasing the probability of error. The system becomes a speed demon that loses its way. The trade-off is not just about time, it is about trust. If your users cannot trust the speed of your model, they will not use it, no matter how fast it is. This realization forces a reevaluation of how we build these systems. We cannot simply plug in a faster model and expect better results. We must understand the architecture of the inference process. We must consider the balance between the speculator and the base model. We must consider the hardware constraints that cause latency spikes. We must consider the context window and how it affects the model's ability to stay on topic. All of these factors combine to determine the actual utility of the system. Speed is a feature, but it is not the only feature. The industry is beginning to wake up to this. Researchers are calling for new standards. We need benchmarks that measure not just how fast words come out, but how well they stick together. We need to measure how often the model drifts off topic as the context grows. We need to measure the rate of hallucinations as we push the throughput higher. Until we have these metrics, we will continue to chase numbers that do not reflect reality. The goal is not to build the fastest model. The goal is to build the most helpful model. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.